Hello again. So we have our ESDK, or Environmental Sensor Development Kit here, and it's got our particulate sensor, CO2, temperature and RH, as well as VOC. And I thought what might be good is that even though all these readings are displaying all the different measurements for the air quality in general, I thought it'd be good to explain what all of these indicators actually mean. So for example, if we take our particulate sensor here, which is giving out a reading just here you'll see that it's got the PM 1.0, PM 2.5, PM4, and PM10. And essentially what these are is it's relating to different particle sizes in microns. And essentially I thought the easiest way to visualize these things, if you made the PM10 the same as a football, the next size down, the 2.5 or 4, sort of would be approximately a golf ball. But then it's quite staggering to realize that the PM1 is basically about the size of a large grain of sugar or large grain of sand. And to give you an impression of what this is often called ultrafine particles, and the reason you hear about this so much in the news, and indeed with sort of filtration around sort of things like silicas or MDF wood particles, is that this is really bad news for your lungs and your respiratory system. So these particles, strangely, the strange analogy here, but the big particles of this dimension, when these get into your body, you can usually sort of sneeze or cough them out, or they pass through into your sort of bloodstream and you excrete them. However, the ultrafine particles basically sort of do neither one nor the other. You can't quite sneeze them out, but they don't neatly pass through your body as well. And so they fall into this no man's land of basically doing a lot of disruption to cells and becoming an irritant, and quite often an allergen as well. So your immune system will, try to fight them and not be able to do anything about it. So this is why you hear things like silicosis and all these sorts of things are tremendously problematic, and why it's a good idea to have a particulate sensor in anywhere like a workshop or somewhere that produces a lot of dust. So I think these are already, well known and important, but I think more so within places that, we're interested in looking, and not just indoor dust, but also outdoor dust in our streets as well. So this is certainly going to be an area of interest to sort of pay attention to and see how these fluctuate. To give you an example of a sort of, at the minute I'm sort of quite pleased with this. This is only at around the sort of 2s. And if you were to look at sort of air quality indexes and things like this, generally speaking, if you're sort of going up into the sort of 10s, it's okay. Around the sort of 30 mark, it's sort of not good if you have allergies and asthma and sensitivities to these sorts of things. This is mostly referencing the PM 2.5, which is often the one sort of investigated. And then it starts getting quite unhealthy around the sort of 50s to 150s, and of course worse still. So again, these are something which I would say it's really quite specific to your application on how these things really are relevant to you. So if we then take a look at the let's take a look at the CO2 sensor here. And what we'd find is that these are measured in parts per million. And again, this is an incredibly dilute amount of particles floating around in the air, eventually coming across this sensor, which has a little infrared sensor. It'll notice a change in how that light is perceived, and that will essentially give the reading for that particular particle. And it says a lot that it's basically passing through this little membrane here and into the sensor. That shows you how tiny these, quite literally just a couple of atoms CO2, so essentially unbelievably small particles that we're talking about here. CO2 you might have heard referenced in the sort of global CO2 of around 400 parts per million, but it's quite shocking to think that really only in a lifetime ago we were at 275. And so it's extraordinary to see how much the Industrial Revolution has really ramped this up for us. And so this is why CO2 is often of high interest at a global level. But at a local level, I think I've mentioned that being in this room as I am now, the CO2 most certainly is complaining, as I'm needing to keep windows and doors shut as much as possible for the acoustics of this recording. And it's meaning that I'm above 1,000 parts per million, which is actually unpleasant, but not unhealthy, should we say. So I'm not suffering for my art just yet. But essentially, if you started getting up to the sort of 2,000, 3,000, 4,000, 4,000 parts per million of CO2 is genuinely quite unpleasant. I've experienced it. You have a pounding headache, and you feel dizzy. It's really not a comfortable thing at all. Similarly with VOC, if the canary is on at the minute, it would be sort of reasonably happy with them about 96. If this goes all the way up to sort of 200s, this is getting sort of quite unpleasant. And I think 500, the sensor doesn't actually process anymore. That's getting really quite. You should definitely ventilate the room. So again, it all depends a little bit on your application. If of course you're worried about people's personal health, you have one particular set of readings. These often relate to the air quality index. And of course, if you are measuring a particular chemical for an analysis, you might calibrate it so that the VOC sensor is mapping a particular chemical of interest for your experiment. So I mentioned a little bit there just the air quality index. And if we take a look at that online, essentially what this is, there is no definitive singular air quality index. And you'll see that if you go to Wikipedia and scroll down, there's actually myriad different standards all around the world, but these are basically an amalgamation of all sorts of different readings, everything from ozone, nitrogen dioxide, sulfur dioxide, the particulates I just mentioned, VOCs, and some places even CO2. These are taken into consideration. And so it essentially will give you the banding appropriate for your country, and essentially you can make a judgment call from the sensors of this where you want to essentially set these indicators to be most appropriate. But we've taken a sort of good mean average of them around the sort of UK benchmarks for obvious reasons, it being developed in the UK. But I think this is one of those things that when we look to the future, will countries actually start to align on what should be an international air quality index standard? I think these are incredibly interesting things to observe and see how the agenda around air quality and organizations like the WHO trying to sort of bring together a consensus around better air quality. So this humble little project of the air quality sensor development kit could play a role in that journey as well. So anyway, we'll take a look at the sensors in depth next. Thanks for watching.